Hello and welcome to this video demonstration of Dell Storage SC Series and VMware vSphere virtual volumes, also known as VVols. In part 1 of this video series, we'll cover the installation and configuration of Dell Storage Manager, Dell Storage Center, and VMware vSphere virtual volumes. I'm in my vSphere 6 lab environment now. vSphere 6 is one of the fundamental requirements for virtual volumes. In my environment, I have a single data center, a single cluster called new VVol cluster. It is a 4-node cluster, and within that cluster I've got a couple of infrastructure VMs, including a Vcenter server appliance, which we'll be using for this demonstration. I've got the SitV appliance installed from Dell Storage. This is not essential for VMware virtual volumes, but I've got it installed and deployed to support the vSphere web client plugin. I've also got a Windows template that we'll use for the VVol operations, and then I've also got Dell Storage Manager. Now this is deployed as a virtual machine running on Windows 2012 R2. This virtual machine is protected with vSphere in the vSphere HA cluster, but additionally it's also protected with vSphere fault tolerance, or FT. The Dell Storage Manager, which is required for virtual volumes because it has the Vasa 2.0 provider baked into it, it is critical that that remain up and highly available as it tracks metadata that's related to virtual volumes. So an outage at this point of the Dell Storage Manager in a VVol environment will cause issues with future VVol operations until the Dell Storage Manager is brought back online. I'm logged into my Dell Storage Manager 2016 R1 client, and I've also got a storage center called SC22 running Storage Center 7.0. That is yet another requirement to support virtual volumes. There you can see I'm in the storage view under the storage tab, and I do not have any servers deployed yet. So the first order of business before we can set up virtual volumes and the Vasa provider, of course, is to have the underlying vSphere 6 infrastructure deployed, have the Dell Storage Manager deployed, have the Dell Storage Manager client deployed. And so the next step after that would be to go to the servers view, and I'm going to import my vCenter server, or register my vCenter server using the DSM client. So we'll click Add VMware vCenter Server, and I'm going to type in the fully qualified domain name of my vCenter server appliance. Type my credentials. Now at this time, I can optionally register the Vasa provider. This is the Vasa 2.0 provider that's built into Dell Storage Manager 2016 R1. We can skip this step for now if we'd like, and we can always register the Vasa provider later by editing the settings of the vCenter server that we have imported or will import shortly into DSM. I'll go ahead and register the Vasa provider now. And so I want to make sure that for VVol support, I'm going to register the Vasa 2 provider, and we can see that DSM automatically provides the Vasa provider URL for Vasa 2.0. We'll just provide a username and password that I've created in DSM for the Vasa provider, and click OK. Okay, the vCenter server has been imported at this point. I can see it registered or listed using an IP address of the vCenter server. And underneath that vCenter server, when I drill down, I can see my cluster, and I can see the 4 nodes in the cluster. Under each of the nodes are associated virtual machines and data stores with those nodes. Looking over at the storage view, I'd like to point out that one of the features of DSM is, by virtue of importing the vSphere infrastructure, one of the things it has done is that it has also imported the cluster and host hierarchy under the storage view under this servers object. And more importantly, in addition to registering these server objects, it has also registered the corresponding HBAs for each of the hosts so that we can start presenting volumes to the hosts or the cluster. My particular environment is Fiber Channel, so you can see that each of the hosts have been registered with corresponding Fiber Channel HBAs or worldwide IDs. You'll also note a new column or a new tab in DSM 2016 R1 for protocol endpoints. Now these are PEs are part of the architecture of VVols, and protocol endpoints are how each of the vSphere hosts are going to send read and write I/O to the virtual volumes on behalf of the virtual machines. Now each of the hosts has received a pair of protocol endpoints, and the LUNs that we observe are LUNs 256 and 257. So the LUN numbering starts at 256 and goes on upward for protocol endpoints. Now at this point in the vSphere cluster, if we actually look at, we can actually go look at those protocol endpoints. They aren't going to be protocol endpoints quite yet. They will show up as 512 byte devices. Here they are right here. They're just regular block devices. But if we go look under protocol endpoints, we're not going to see anything yet. So although DSM has assigned the protocol endpoints as the result of mapping vSphere 6 host types into DSM, vSphere does not recognize them as protocol endpoints until we create our storage container. That's a requirement that's called out in the vSphere storage guide. So we've got a few steps left. We can also verify the Vasa provider has been registered properly. So to do that, we'll click on the Vcenter server, click on the Manage tab, click on Storage Providers, and we can see that our Vasa 2.0 provider is online and registered. Okay, back in DSM, we need to create a storage container. And the storage container is where we're going to deploy our subsequent virtual volumes. Now this storage container, as we'll see in a minute, is coupled to storage capabilities, or capabilities that are provided by Storage Center. In just a moment we'll see what those are, but to get the process started for creating a storage container, in DSM, under the server's view, we're going to right click on our cluster because we want this storage container to be available to all hosts in the cluster, which are going to support VVols. We'll choose Create Data Store, and let's just give it the container we'll call SC1. Now this is going to be a VVol data store, not a VMFS data store. We'll click Next. And so we're presented with some options here in terms of size. Now the storage container is really just a logical boundary of space in which VVols are going to get provisioned and managed and deleted and so forth as a normal part of day-to-day operations with VVols. The default size of our container is 16 terabytes. I'll leave that for now. Could be smaller, could be greater if I'd like. One thing I will do is, for the purposes of the storage policy-based management examples, I'll go ahead and enable the capabilities of compression and deduplication for the storage container. So then we can build SPBM, or storage policy-based management policies, that may require some of these capabilities, and we'll see how those policies allow compliance. Okay, we'll click Finish. Okay, our storage container should be created at this point. If I drill down under one of the hosts, look at data stores, I see that SC1 is now there. This storage container should exist under each of my hosts. So each of the hosts have been presented this storage container. Going back to the vSphere web client, let's click on the data stores view, and there it is, SC1. We now have a storage container called SC1, and this shows up, it looks like a traditional VMFS data store. Okay, and there's really nothing special about that. Again, it's just in this case, in this example, it's a 16 terabyte container or boundary. where virtual volumes will be created, so that we'll see config vVols, we'll see data vVols, and we'll see swap vVols fall under this storage container. Now, before we start getting into deploying virtual volumes and creating policies with storage policy-based management, I want to highlight one thing, and that is if we click on one of our hosts and look at storage, we do now see that our vSphere host recognizes that it has protocol endpoints, and those are, we can see the LUN IDs 256 and 257. Likewise, we should see different PEs for each host in the cluster. But what I want to highlight is the pathing. Now, storage center devices, starting with storage center 6.6 and newer, are adopted by the VMware Alua storage array type plugin. And it just so happens that the default path selection policy for the Alua SATP is MRU, or most recently used. So that means each of the protocol endpoints that we have at this point and the vVols, which are going to be communicated with using the protocol endpoints, are going to be using the most recently used path selection policy. We want to change that. I've got multiple HBA ports in each of my vSphere hosts, and I got a couple of fabrics in my lab, and I want to implement the round-robin path selection policy. Now, I could do that by clicking on each of the hosts here, and under protocol endpoints, we can change the path selection policy by editing multi-pathing, and we can switch from most recently used to round-robin, and that's easy enough. It's somewhat tedious, so I like to do this with scripting, and there's a couple ways you can do it. You can either do it via Esxcli, or you can do it with PowerShell. By the way, let's do a refresh here and see if that path has changed. Yep, that's now using round-robin. So if we go to the other host in the cluster, and actually the other protocol endpoint on this host, we can still see that it's using MRU. So I don't want to have to do this for every host in the cluster. We could have a large number of hosts in the cluster, 32 or maybe even up to 64. That would be a lot of manual editing. I'm going to go ahead and use a PowerShell script to modify the path selection policy for all my protocol endpoints, changing them from MRU, or most recently used, to round-robin. And I'm just going to borrow some snippets that I've already got from one of my lab cleanup scripts. So we're going to go ahead and load the Power CLI snap-in or module, and then we'll make our connection to VC Site 11, which is my VVol Vcenter server. And now we'll go down in the script. And before I go ahead and make the path selection policy change, let's get an enumerated list of all of my devices and SCSI ones, and you'll kind of see what I'm talking about here. So this is going to enumerate all the devices as seen by all hosts in my cluster, or in this case, the way the script's written, it's written to the data center, but I've only got one data center, one cluster, and 4 hosts in here. And there they are. You can see I've got a number of 512 byte devices. They actually show they're rounded down to 0 gigabytes capacity, but each one of these 0 gigabyte devices with the multipath policy of most recently used are the protocol endpoints for each of the hosts. So what I want to do is actually run this script. Let's scroll back down. We'll run the rest of the script, which enumerates or gets that same list of devices, and any device that it finds that's using most recently used, it's going to change to round robin. And it's also discrete about only choosing devices with the vendor ID equaling compellent. So if we did have a heterogeneous data center in terms of storage, and we had some EqualLogic storage or Power Vault, we wouldn't impact any of those devices as they're not going to match that vendor string. So let's go ahead and run that portion of the script. And there we go. We can see for each line that's returned, it found 5 remaining protocol endpoints that were using MRU. It has changed them to the round robin policy. And if we run our script again, we should see now that all of our protocol endpoints are using round robin. Now, one additional thing that I can do if I plan on deploying more devices, VMFS volumes, RDMs, maybe protocol endpoints and so forth to this cluster, I can change the default path selection policy for that Alua storage array type plugin, so that instead of all devices lighting up as MRU, they are configured by default and discovered using the Alua SAT-P and with the change default to the round robin path selection policy. And the way I can do that with PowerShell, I can also do it with Esxcli, but since we're in PowerShell now, let's just go ahead and do that. And you can see the example of the script here. I want to make sure I get it all so I don't cause an error. We'll run that. And the way this script is developed, we can see that it enumerates each host in the list and changes the default path selection policy from MRU to round robin. Let's go ahead and actually just verify that quickly with Esxcli. So I will putty or remote SSH into one of my vSphere hosts. Log in as root. And what we want to do is run an Esxcli storage nmp SAT-P list. I'm going from memory here. I'm actually not looking at a script. And that was the correct string. Actually, let me expand this and make it look a little prettier. There we go. Okay. So what we're looking at here, what we changed with PowerShell is that for the Alua SAT-P, where it used to say the default path selection policy was MRU, it is now changed to round robin for each of the hosts. This is just one of the hosts, but each of the other 3 hosts I would find the same thing. All right, that wraps up part 1 of this video series. Thank you very much for watching. Be sure to catch part 2 where we cover storage policy-based management, or SPBM, as well as some sample VVol operations.